As you know, T1 is a unique and powerful software tracing tool for tracking the timing behavior inside ECUs, and its adaptability ensures that it can be integrated into any project without additional hardware. For example, we can use the communication channels that already exist in the customer's project, regardless of whether it is a CAN bus or an Ethernet bus. T1.scope and T1.cont are the two fundamental plugins of T1. The two plugins can measure the runtime of each task, interrupt, and the load of the entire system. So what is the difference between them? Today we will look at the difference between them from the user's point of view. Let's start with T1.scope and show the difference between the functionality of T1.scope and T1.cont from the user's point of view. T1.scope is the most fundamental plugin of T1. Its principle is to transfer the whole trace buffer we allocated in ECU to the PC, and then analyze it by T1 host software. What we see now is the view of T1.scope. In this view, we can see the runtime of each task and each interrupt. There are two aspects to this runtime. The first one is its own runtime, the runtime of each execution. We can zoom in, and we can look at this 1 millisecond task, and this is its current runtime, which is about 38 microseconds. Another aspect is when it runs. For periodic tasks, this is expressed in terms of with which period it runs, and how much jitter each run deviates from its activation time. In addition, we can observe the scheduling of the system, i.e., when each task and interrupt runs, and whether they are preempted by each other. For example, the 25 milliseconds task, we see that it's being preempted several times, by this interrupt, the OS timer interrupt, and by the 1 millisecond task, because the 1 millisecond task has a higher priority. Also, we can observe the CPU load. We can observe that the minimum CPU load during this time is about 12%, and the maximum CPU load in this trace is about 18%. Some additional explanation about CPU load. CPU load is never specific to a time point. To measure CPU load we always need to take a time slot, or a cycle. Now we currently see that the time slot covered by the green and red is the period used for the CPU load measurement, but of course this period can be configured, but how to configure it is another topic, we can talk about it separately. Anyway, we can see the measured CPU load in T1.scope, and if we expand it we can also see the runnables under the task. We can zoom in and see that the current 25 milliseconds task contains 4 runnables running in sequence, and we can also see some user-defined measurements, such as user stopwatch and user event, which we can talk about it in a separate topic later. Another important advantage of T1.scope is that in the downloaded trace we can observe how Core 0, Core 1, Core 2 and Core 3 are running at the same time. We have 4 cores in this microcontroller. This means that the 4 traces we see are synchronized in time. We can see what Core 1 is doing when Core 2 is running 10 milliseconds task and what Core 0 is doing at that point in time, which provides a good way to analyze the scheduling behavior of a multi-core system. Now let's switch to the T1.cont table view. Compared to T1.scope, T1.cont shows us much less information. By default it only includes the maximum and minimum CET per task, per interrupt, i.e. core execution time, as well as the IPT, initial pending time, task activation to task start, and the RT, response time, task activation to end of its execution. In this case foreground T1.cont is enabled, otherwise with background T1.cont we only see the maximum CET by default. Anyway, T1.cont shows fewer details compared to T1.scope. What is the advantage of T1.cont? If we switch back to the T1.scope view, we can see that the trace of T1.scope is in fact the whole trace buffer, and it covers a time slot of about 100 milliseconds, which means that we can only see a trace of 100 milliseconds. Of course, we can download the trace a few times and get a few more traces, but under normal circumstances, the 100 milliseconds trace is enough for us to observe how the system is running. However, if the system is not running under normal conditions, for example, we may have some occasional timing exceptions in the actual project, these occasional exceptions do not appear very often, for example, each several hundred milliseconds or several seconds, or even only once in several hours. Such occasional exceptions are also very harmful, but it is very difficult to catch these occasional exceptions by just downloading a trace of 100 milliseconds. That's why there is the T1.cont plugin. Let's look back to why T1.cont can only display limited information. The reason is that the analysis of T1.cont is done by the ECU, which doesn't have such rich computational resources as the host PC, so T1.cont can only display selected but important timing information. Of course, we can also configure additional timing information to be displayed in T1.cont. For example, we can turn on GET, gross execution time, and see how much the GET is for the 1 millisecond task. We must also point out that T1.cont's analysis starts immediately after the initialization of T1. As long as the trace buffer is being updated, T1.cont will analyze the trace buffer data in the background to calculate the maximum and minimum values, and store these maximum and minimum values in a specific memory area. When we connect to the host PC, then T1.cont will send these stored results to T1 host software via the communication channel, and it's displayed here, what we see now. That is to say, we can use it in some other scenarios, for example in the test vehicle. It is completely possible to let the test vehicle operate in several different scenarios, and then connect to T1 host software afterwards to see the maximum runtime of each task and each interrupt, to ensure that there is no timing problem present. In addition, there may be the problem mentioned earlier, that there are some occasional timing exceptions in the system, so let's use an example to show how to use T1.cont to handle this kind of situation. Let's say we want to monitor the runtime of the core 0.25 milliseconds task. Currently we can see that the minimum runtime and the maximum runtime of it are both about 500 microseconds. We can do it like this. Let's find this 25 milliseconds task here from the Project Explorer on the right side. Find this 25 milliseconds task and select Add/Edit Constraints. To give it a runtime limit, giving it an upper or lower limit of the runtime, here we try to set the upper limit, 500 microseconds. But the actual situation is that runtime is more than 500 microseconds, but we give it anyway to set the upper limit of the runtime. You can think about what effect will have. In fact, it is very simple. T1.cont will stop the tracing. Let's try, click OK, and we can see that the tracing stopped immediately. As a general hint about T1, the tracing won't stop for no reason. The reason here is that T1 found some anomalies and you should download the trace buffer to have a look. Because the T1 trace buffer is being continuously updated, if we don't stop tracing in time, the time period that contains an anomaly will probably be overwritten, and we won't have a chance to see it. So when T1 observes an anomaly, the easiest thing to do is for T1 to stop tracing and save the scenario with the anomaly in the trace buffer. In such a case we just click on the download button and use T1.scope to see what's going on. Now we can see that in a downloaded trace, T1 has highlighted it with a red CV, constraint violation, which means that it has exceeded the upper limit of the runtime that we have set, so T1 has stopped tracing to help us save the scenario. This is a joint usage of T1.scope and T1.cont. We can set up some conditions in T1.cont to monitor the system, and if the monitoring finds any violation, T1.cont will stop tracing, and then we have a chance to use T1.scope to see what's going on. About the detailed configuration we can talk separately. Another point I would like to share is that the analysis of T1.cont depends on the update of the trace buffer. If the trace buffer is not updated as it is now, the analysis of T1.cont will not be done because there are no new trace events to be analyzed. Take a very simple example. This function is familiar to many T1 users. T1.cont will call this function to calculate whether the CPU load exceeds the threshold. This function is defined in T1config.c. You can edit this function by yourself and add some functions you defined. For example, many users added the function of analyzing CPU load in this function. Some users noted that this function is not called as expected. What is the most likely reason? It is very simple. T1 found some kind of anomaly and stopped tracing, usually a trigger occurred so that the tracing stops. In this case, the analysis of T1.cont will not be continued, and this function will not be called. Finally, let's summarize the difference between T1.scope and T1.cont in terms of usage and principle. Now we see the tracing principle of T1. On the ECU side, T1 is collecting trace events, such as task stop, activation and start, the start and stop of interrupts, and then store these trace events into such a trace buffer. For T1.scope, all we need to do is to transfer all the contents of the trace buffer to T1 host software. This is the working principle of T1.scope. T1.cont is also very simple. T1 analyses the trace buffer on the ECU side, and then transfer the result of the analysis to T1 host software side. This is the result of T1.cont that we see. From the application point of view, we can see that for T1.scope, the capture of the trace event happens on the ECU side, and then the visualization and analysis is done by T1 host software. T1.cont is different, of course. The capture of trace events still occurs in the ECU side, but its analysis is also in the ECU side. We just send the results to T1 host software to display. This is the difference between T1.scope and T1.cont. The joint usage of T1.scope and T1.cont is the correct way to use T1.